Hi, I'm back again. Okay, so lesson 10 sucks and it reminds me of why I really hate math. I'm not doing the timestamps by the way. Basically, you really don't want to skip the formulas. So, uh, you know. Alright, formulas. I'm not doing vocab by the way. Please go check that out yourself. So, we have um normal well, I guess the triangle area formula we originally learned. 1/2 base times height. Remember that height is this part of the triangle. It's not one of these one of these sides, one of the slope sides. And then we learn this triangle area formula, can't remember when. 1/2 AB sine C. So this you know. And then circle area formula, which is pi radius squared. Cool. Moving on. The area formula for sectors is really annoying. X degrees over 360 times pi radius squared. The circumference of a circle is pi diameter, or 2 pi r. Arc length formulas. You might notice the arc length formula is suspiciously similar to arc sector, or to sector formula. Anyway, arc length formula in degree, or well, at least in degrees, it is. So, arc length formula would be x over 360 times the circumference of a circle. And if you forgot what that was, that's x over 360 times 2 pi radius. Or 2 diameter. Pi diameter. Radians, I still don't fully understand. So, the equation says theta radius, which we were just using as the angle in radians. So you'd plug, that's the eraser. So you'd plug, you'd plug your angle into theta. And your arc length would be this. And this is the radius you get. Are we good? Vertex formulas! Hooray! Inside! Inside is weird. Central angles will always be the same as their arc length. Or not arc length. Yes, arc length. Guys, I'm actually bugging. But for a non-central angle, the formula would be 1/2 of both intercepted arcs added together. In this case, this would be measure of arc AB plus measure of arc CD divided by 2 to get measure of arc DEC. For vertexes on the circle, 1/2, it's just 1/2 of the intercepted arc. Or for arcs like this, so angle IJK would just be 1/2 of measure of arc IK. Here it's the same. It looks weird, but it's the same. This is still an angle, or this is still a vertex on the circle, so measure of JIK would be 1/2 of arc IK, which is this one here. Alright. For vertexes outside of the circle, you're always going to be subtracting. In this case, that would be arc BC, the larger arc, subtracted by arc PQ, the smaller arc, and then divided by 2. Stop doing that, dog. Measure, for, these. Guys, I'm actually so tired right now. I spent my entire day making this yesterday. I am so tired right now. My apologies. Dude. So this would just be measure of the larger arc subtracted by the measure of the smaller arc once again, and then divided by 2. And yes, you get it. Again, measure of the larger arc subtracted by measure of the smaller arc divided by 2. Cool. I don't even want to read off the theorems. I don't fully understand the theorems, but they are very important, unfortunately. But, I think, okay, so, 2 chords in a circle or in congruent circles are congruent if and only if their central angles are congruent, so that basically means that 2 chords in a circle or in congruent circles are congruent if and only if how do I draw this? I'm not gonna draw it, never mind. 2 chords in a circle or in congruent circles are congruent if and only if their arcs are congruent. Chords in a circle or in congruent circles are congruent if and only if they are equidistant from the center or centers. So I can actually draw this one. So this would mean that this chord and this chord would be congruent because these they are equidistant from the center. Oh, that also works with the next one I'm gonna talk about. If a diameter or radius is perpendicular to a chord, then it bisects the chord. So that would make this both perpendicular / 90 degrees, and that would also make this congruent. Also make these congruent and 90 degrees. Cool. Alright, just straight into the math problem. Sorry guys. Okay, the area of a triangle below is 33.37. I'm gonna write that out for you guys just in case. Square centimeters, this shouldn't be too hard. So I'm gonna like 1, 2, okay, I'll give you 5 seconds to pause the video if you really need to, or if you just want to see the answer. Go ahead. 1, 2, 3, 4, 5. Yeah, so I did all of these beforehand. Recall that triangle base height formula is 1/2 base times height. So plug 33.37 into found area. You can plug 7.1 into either base or height, but it makes more sense for height in this case. It doesn't super matter though. And then you'll see what steps I took. This shouldn't be that hard. It's a review of what we did before. I did not draw the circle for you guys, but I do actually draw the circle in the explanation. The radius of a circle is 19 centimeters. Find its circumference in terms of pi. 1, 2, 3, 4, and 5. So if the radius of the circle of a circle is 19 centimeters and circumference takes diameter slash 2 radius, then you'd have to double 19 to get 38, and since it wants the circumference in terms of pi, you'd leave it like this. Diameter of a circle is 9 inches. Find the circumference to the nearest tenth. 1, 2, 3, 4, and 5. So that just means the entire go around of the entire this the entire this would be 9 inches, which is the entire diameter. And again, since circumference takes 2 radius slash 1 diameter, you can just plug 9 in, and that would be 9 pi. But since it wants it to the nearest tenth, you'd multiply 9 by pi, and you'd get approximately 28.3 inches. Alright, I did draw this one out for you guys, because I thought it would be confusing. So if the circumference of a circle is 10 centimeters, so that means like the entire, like going around, I guess it's like the measure of the roundness of the circle? I never know how to explain circumference. But if the circumference of a circle is 10 pi centimeters, find its radius. This should be easy. In centimeters though, 1, 2, 3, 4, and 5. Alright, so the circumference, once again, 2 pi r, or 1 diameter pi. You'd plug in 10 pi for circumference and equate that to 2 pi r. You'd get rid of pi on either side, which would lead you to 10 equals 2 radius. And then you'd divide that by 2 to isolate r, and you'd get 5 centimeters for the radius. Another circumference one. But this one's harder. Okay, so the circumference of a circle is 7 pi inches. What is the area in square inches? Think about that for a second. Express your answer in terms of pi. 5, 4, 3, 2, and 1. Okay, so circumference, again, 2 pi radius. You'd plug in 7 pi for the circumference, get rid of pi on either side, so you'd have 7 equals 2 radius. Divide 7 by 2 to get 3.5 inches for the radius, but you're not done there because you also need the area. Area formula for circles is pi r squared, which would mean plugging in radius, you'd get pi 3.5 squared, and since you're supposed to... Why did I forget the pi there? Well, there he is now. So, express your answer in terms of pi, you'd get 12.25 pi inches squared. Alright. Apologies. So, if the diameter of a circle is 8 meters, find its area in terms of pi. This should be easy. 5, 4, 3, 2, and 1. Alright, diameter is 2 radius, which means 8 equals 2 radius, which means r equals 4. Got that? Good. Area formula is pi radius squared. So you plug 4 into radius, 8 equals pi 4 squared. 4 squared is 16, and since it wants the area in terms of pi, you'd leave it as 16 pi meters squared. Good, moving on. The diameter of a circle is 14 meters. Find its area to the nearest whole number. Again, should be easy, the exact same thing. 5, 4, 3, 2, 1. Alright, again, diameter is 2 radius, 14 equals 2 radius, radius equals 7. So, area equals pi radius squared, plug 7 in for r, a equals pi 7 to the second squared, 49 pi, and then you do that in your calculator. you'd get about 154 meters squared. Remember, they wanted a whole number. Alright, this might look familiar. First off, number 1, do the entirety of number 1. I'll give you 8 seconds to pause. 8, 7, 6, 5, 4, 3, 2, and 1. Alright, AC is a minor arc because this is less than 180. CBA is a major arc. Dang it. CBA is a major arc because it is more than 180. BC is a minor arc because that's definitely not over 180. ACB is a semi. What? Oh, other way. ACB is a semicircle. Whoa, go figure. And BAC is a major arc. Got it? Alright, number 2. I'll give you 5 seconds to pause again. 5, 4, 3, 2, and 1. Alright, so arc JL is going to be 127 because this is a central angle, and JML is going to be 233 because 360 minus 127 equals 233 degrees. Remember your degree symbols. Sorry, I did not say that. Alright, do number 3. I'll give you 8 seconds to pause. 8, 7, 6, 5, 4, 3, 2, and 1. Alright, so let's see, how do I explain this? This is a central angle. Since this is a central angle, 25 is also going to be this angle, and since these are vertical angles, that is going to mean that UQ is 25. Now we're looking for TQ. 44 plus 25 is 69. Cool. Now we can go, since this is a semicircle, 180 minus 25 is going to be 155, which is QR. TS is going to be 44 plus 25 plus 155 plus 25 minus 360, which will net you 111. SQR is just going to be 360 minus 25 for the short answer. And RQT is going to be 224 because that's going to be 155 plus 25 plus 44 degrees. Alright, on to 4. Give you 8 seconds again. Number 9, 5 because I yawned. 5, 4, 3, 2, and 1. Find the indicated arc measures. This is going to be a semicircle, so 180 minus... Oh, wait, I didn't find that first. Apologies. So, this is a 90-degree angle, and since it's also a central angle, that is going to be 90 degrees. 90 plus 67... 90 plus 67 is 157, so that's NL. And then 180 minus 157 is 23, which would find you this and this angle because they're vertical angles, which means that KO is also going to be 157. KNL would just be 360 minus 23. OM would be 90 plus 23. And LON would be 23 plus 23 plus 157. Cool, moving on. Solve for X. 1, 2, 3, 4, and 5. So this is going to be a semicircle, so 180 minus 31 would be 149. Now, that means that 149 is this central angle here, and it's vertical angles with that one, so we can go 149 equals 9x plus 23, which is 126 equals 9x, which means that x equals 14. Alright. Again, solve for x, please. 5, 4, 3, 2, and 1. Alright. So 83, this is another vertical angle. So 83 equals 16x minus 13, which would be 96 equals 16, which would mean x equals 6. Solve for x again. 1, 2, 3, 4, and 5. Alright, so we have a lot of stuff here, but don't worry. This entire thing is just all of these terms equated to 360, which should make x equal 21. Oh, not yet. Solve for x and then find the measure of each indicated arc, please. 8, 7, 6, 5, 4, 3, 2, and 1. Alright, my apologies. So again, this is just 90, plug all of the, this is just all of this here. My equation is just the entirety of that circle equated to 360 once again. And then to just plug all of the values into here. I'm really tired right now. Alright, vocab scare, I kept this in. So, classify each part of the circle below. A, B, C, D, E, and F for, this circle. 5, 4, 3, 2, and 1. Alright, so CD is a chord because it doesn't go through the center point. If it did go through the center point, it would qualify as a diameter. While a diameter is a chord, it's a more specific chord. Speaking of diameters, EC is our diameter because it goes through the center point. Point A is our center point because it's the point in the center. FG is our tangent. AB is our tangent because it only goes through one point of the circle and never connects again. AB is our radius because it's 1/2 of the diameter. And point H is the point of tangency because that's where the tangent meets the circle. Cool. Moving on. Give an example of each from the diagram. I can't remember if I put the multiple answers you could get here. I think I did. Alright, 5, 4, 3, 2, and 1. Alright, the center is point K. Segment MN is the chord. Line MN is the secant. Sorry. Remember to have the little pointy bits at the end of your notations, or else you will be counted wrong. Our point of tangency is point U for obvious reasons. JL is our diameter for, again, obvious reasons. It passes through this. Radius. Our radii could be multiple answers. It could be RK, it could be JK, and it could be LK. I don't care which one you put. I can't see which one you put. And our tangent here can be notated as SU, as line SU, line US, or line TU, or line UT. Okay, back to the delta math, and sorry this jumps around so much. In circle E with a measure of angle DEF equaling 42 and DE equaling 5 units, find the length of arc DF. And round to the nearest hundredth. Five, 4, 3, 2, and 1. Alright, so recall that arc length is x degrees over 360 times circumference, which would also be times circumference, which would also be oh my gosh, I can't believe I knocked this off kilter. I'm so mad. Which would also be 2 pi radius slash diameter pi. You should get about 3.67 units. Hey, and I'm so tired right now. Sorry, guys. Alright. So, in circle N, NO equals 11, and the length of OP equals, or arc length of arc OP equals 11 over 6 pi. Find angle ONP. This should be easy if you remember I can't remember what it's called. Radian formula is called radian. Alright, so plug 11 over 6 pi in for arc length and equate that to missing degrees over 360 times 2 pi 11. Do all of the things that you see me doing in the equation. Okay, encircle M with angle LMN equating to 36 degrees and LM equating to 5. Find the nearest area of sector LMN. Remember to round to the nearest hundredth and don't forget your units. Okay. 9 equals x degrees over 360 times pi r squared. You should get about 7.85 units squared as your answer. Alright, encircle K. KL equals 4, and the area of the shaded sector is 16 over 9 pi. Find the area of LKM, or find measure of LKM. Okay. So, again, sector of the area of sector is x degrees of 360 times pi radius squared. Meaning the measure of angle LKM should be 40. Alright. Whoa, do you guys recognize this? You should. I'm not even going to read inscribed angles again. So, do 1 and 2 for me, guys. Alright. So, you should have gotten 61 and 226. This is because 62 is the arc length, which means it's half of the angle. And since 113 is the angle and the angle is half of the arc, You need to multiply 113 by 2. Alright, do 3 and 4. Okay. I don't even think I want to explain these. These are kind of easy. I don't know why. Sorry. Hope you guys did 5 and 6. There you go. Check your answers. I'm really tired, guys. Alright. Oh, I should have... Okay, just do 7 through 10. I'm gonna, nap for a little bit. fun fact, I fell asleep recording this. So this is the segment you would have done beforehand, and then I fell asleep. So please proceed to do 11, 12, 13, 14, and 15. So here's 11, 12, and 13. Should be easy enough. Opposite angles are supplementary. So M is supplementary to K. J is supplementary to L. Here's 14 and 15. Alright. Number 1 would be 71 because this is an inscribed angle. So 142 divided by 2 is 71. Again, this is the inscribed angle, except this time we have an inscribed angle, not the arc. So 127 times 2 is 254. The measure of arc XY is this arc, the small one. Since we have the angle here, we go 180 minus 151, which would be 29, which would be that angle. And then you'd multiply it by 2 for 58 degrees because you're looking for the inscribed arc. I don't want to explain this anymore, dude. I'm so tired. So just look over the answers. Okay. So, if measure of major arc DZM is 228 degrees and minor arc 52 is mark V is 52 degrees, find angle RIV. Recall that this is inscribed angles, so you would take the major arc and subtract the minor arc from it and then divide it by 2, or add, because it's inside. Sorry. So 280 divided by 2 is 140, meaning angle RIV / angle DIM is 140 degrees. Alright, if measure of arc KS equals 62 degrees and measure of arc JA is 176 degrees, find measure of angle D. Alright, so you'd take the larger arc, 176 degrees, and then subtract the smaller arc from it, which is 62 degrees, and then you divide it by 2. This would equal 57 degrees. Line ZB is tangent to circle O at point Z, and ZF and line ZF is a secant line. If measure of arc ZKF is 246, find measure of FCB, or Find measure of angle FZB. 1, 2, 3, 4, and 5. Alright. Described angle again here. So you'd find measure of angle, or measure of this angle by dividing 246 by 2. 180 minus 123 will net you your angle. I'm so tired, dude. Alright, find the length of the third side. This should be so easy. To second plus b to the second equals 106 to the second. Square root, or square both 5 and 106. I wrote the square root too early. Oh wait, no, that's square root 106. I'm stupid. 25 plus b to the second power equals 106, so b to the second equals 81, and square rooting that would be 9 units for the third side. I'm gonna let you guys read this. It's not gonna be, cannot be determined, by the way. No! Oh my gosh. My notes. Alright, do it. I'm doing my notes. Oh. Come on, man. Okay. Okay. So, the answer would be about 14.9 units. You can see the work I did. Ow. So just go ahead and look at that. Alright. Given the circle below with chords D, E, and F, G, find the length of DH. Round to the nearest tenth if possible. I don't know if you guys even remember how to do this one, but you should. Alright, so DH would be about 12.6. That there should be units behind that. I knew I missed one. But this is because you'd go 15 times 60, which is 240, and then you'd do 19 times DH, which would also be just 19 times X. So 240 divided by 19 would equal like 12 point something, and then you'd round it to the nearest tenth, which would mean segment DH is equivalent to about 12.6 units. Cool. Right, given the circle below was secant O and M and tangent LM, find the length of ON. Round to the nearest tenth if necessary. Okay. So, this, you'd multiply, you'd multiply this by itself as per vertex rules. This is a vertex formula, by the way, I think. And then you'd go 7 plus x times 7, parentheses, 7 times parentheses 7 plus x which would mean 100 equals 49 plus 7x. Subtract 49, 51 equals 7x. So line ON is approximately 7.3. Wait a minute. Yeah, I think that's right. I checked it on the Delta Math. Since the Delta Math accepted it, that should be the correct answer. Okay. Given the circle below a sequence MNO and QPO, if NO equals 15 and PO equals 14, and MN is 3 less than QP, find the length of MN. Round to the nearest tenth if necessary. This one shouldn't be that hard. It's just figuring out what MN would be. Okay, so looking at the equation we set up, you put, well, obviously, we've been told that PQ is 14 and ON is 15, so those are on. You should make PQ X, because then you'd make MN X minus 3, because MN is 3 less than X. And then you'd plug this into one of the vertex formulas, I think. So just read through that. Now that's the end of my slideshow. That's 83 slides, by the way. But I didn't put any of the checks for understanding or the reviews or stuff. So I'm actually gonna go through 12 through 14 of the review game played today, because I think everybody would like that. Okay. Actually, wow, 13 is easy. 13 is ridiculously easy. Okay. So let me draw that out for you, fellas. Oh, I don't have a good ruler for that, so I just won't. So 13, you have to find the value of x. Oh my gosh. Jeez, you can tell I'm running on 2 minutes of sleep. Okay. So, you're finding the value of x here. Let me just change the color here so that it's easier to see. So, since this is a radius, and this is a radius, that means these two are equal to each other. So, that means this is 8.4. Where'd my calculator go? Okay. So, you do 8.4 plus 5.6, meaning this entire hypotenuse is 14. So, this would be x to the second plus 8.4 to the second equals 14 to the second. Actually, wow, I don't know 8.4 to the second off the top of my head. That's insane. Okay, x to the second plus 70.56 equals 196. Subtract 70.56 from 196, and you get 125.44. I square root that. And that would mean that your x is equivalent to 11.2. Everybody cool with that? Okay. I don't like this one, actually. I'm gonna draw an actual circle. I'm gonna, actually get a circle for this. A little bit decompressed. So this is E. I'm gonna draw it exactly how she drew it. Where's my straight line ruler? Or, well, exactly how the diagram puts it. Almost exactly how the diagram puts it. I'm not gonna get the lines absolutely perfect on point. That's asking way too much of me. I already made this entire slide deck, guys. I can't handle any more. Okay. So, the diagram is this entire section is 29. This specific piece is 17. This entire section is 21. And is that all the info they give you? No. They also give you the fact that this piece right here is 2.5. Alright, and they want you to find the perimeter. So, 29 minus 17 would mean this side is 12, and this side is 12. So, just add these up for faster addition in the near future. That's 14.25. 14.5. Oh, I'm having a mental breakdown. You'd put 2.5 here. 17 goes here, and 21 subtracted by 17 is 4. Would mean this is 4. That would mean this section is 6.5. So, 29. I'm gonna write this in the circle. 29 plus 14.5 plus 21 plus 6.5. And you'd get that the perimeter equals 71. I'm looking for any of the super hard ones. I don't recall any of these being too terribly difficult. Please study, look back at the Delta Maths, go back into your notes. That's all I can tell you. Good luck. Memorize your formulas.